in our world of kind of, row by row customer data, I don't think you win by unleashing a more sophisticated model or like getting into neural networks and all that kind of stuff. I think you win by digging up new variables about those customers you never thought about.
I'm thrilled today to have Kim Larsen on our show. Kim runs business data science at Whoop. Kim, welcome.
Hey, Jason, thanks for having me.
Maybe you can tell our listeners a little bit about what you do at Whoop and a bit about your experience working in data, customer data, sports data, and everything in between.
Yes, I run the business data science at Whoop, as you said. So that is all the data science that pertains to marketing, finance, growth, conversion, retention, all this kind of stuff. We have another data science team that works on all these sleep algorithms and all that kind of stuff that you find in the Whoop product. So it's a different area of data science. That's this kind of the business data science is what I've been doing for most of my career.
Great. And for any of our listeners who may happen to follow Kim on LinkedIn, earlier in the summer, I guess late spring, Kim actually did some analysis around the NBA Finals. And he got quite a bit of attention, predicting and making guesses around who was going to win. I think all in all, his models had accuracy around high 60%. And he actually also picked the winner, the Golden State Warriors. Kim's pleasant surprise being a San Francisco and a Bay Area resident. But today, Kim and I were talking. We thought it would be really interesting to talk about a broader set of machine learning and predictive problems. Specifically diving into how sports prediction works, and also asking how does this relate to broader customer data, and other applications around predicting customer behaviors. I don't think there's anyone better, to talk about this than Kim. Having working on these problems at Whoop. That combines, obviously, a sports product that measures activity around how you actually exercise and work out, and then overlay that with how customers actually engage with the product as well. So really excited about the conversation today. And to kick off, Kim, maybe you can talk about how does the model work? I mean, for most of us, we saw a post. There's an 84% chance that Golden State, is going to win, the next series against, whomever. What are the inputs to that, and how does this machine actually work?
Yeah, it's to give you a little bit of background. The reason I got into this was really sort of a game I was playing with myself to see if someone doesn't know a whole lot about basketball. I'm not an expert on basketball. I mean, I played at the Y and stuff like that and watch it. But could you build a model with minimal human intervention and get pretty good predictions? And that's sort of what I tried to do. And that actually sets the stage for how the model was done. So just to give you a little bit of background, starting with what am I trying to do with the model? I'm trying to say if there's a matchup between two teams, what's the probability that either team wins? So that's I'm not trying to predict the spread in points or anything like that. It's literally what's the probability that either team wins. That's number one. Number two, I wanted to just do this off of box score data. So box score data would mean that when the game is over, it has stats by player. How many points they scored, offensive rebounds, defensive rebounds, steals. There's also like the plus minus you find now in the box score for the most part, which is just when that player is on the court, how many points did the team score and how many points did they give up, and you get this plus minus spread. Not a great metric, but it's indicative of something. Instead, as I ran the whole thing off of box score. I didn't get any deeper than that. Then I was thinking like, well, how do you what are some of the things I want this model to do? So I mentioned I want this model to predict the probability of a team winning, but I wanted to go a little bit deeper than that because I wanted to also say that if there are changes to the roster, like if there's a trade or someone is injured, how do these probabilities change? So I think, anytime you build a model, you want to have a mental model of like, what do you want this model to be able to do? So if I want to be able to have the model change based on changes to the roster, I couldn't just run this model sort of at an aggregate level, right? So in an aggregate, I could just say, let's look at team A and team B. Team A on average has X defensive rebounds per minute or whatever. But if someone is injured, I wouldn't know how that changes. So then I said, well, maybe could you build a model at sort of the player level? I don't think that's really going to work. It's going to be way too messy if sort of each player is a variable in the model. I think that just wouldn't work. So I decided to do it like this, and I'll just walk through sort of step by step. So step one of this model is that, okay, I'm going to look at 4 seasons of data. Each season has about 1,200 games or something like that. There's about 400 plus players in a given season. But if you go over a 5-year period, you'll probably have 1,000 plus players that have participated during those years.
Yeah, let's just look at the different types of players, and then compose that into a team that might have a whole bunch of small power forwards or guards or whatnot. And then from that, use that to drive who's more likely to win. Exactly.
And so, if there's an injury, the model would understand this. So it would say, hey, this person isn't playing, which means that you will have a deficit somewhere. And if that's an area that is very important, your probability of winning is going to go down. So you could even think about this, like if we draw a parallel to the kind of business world, you could say, wouldn't it be fun to every single time you play a team to run an optimization algorithm on this and find out what do we think the optimal minute allocation is if we want to beat this team? Now, I'm sure a real coach in the NBA can probably do a better job, but there's some fun applications there.
Yeah, no, totally.
Yeah,
that's super interesting. And maybe we can dive a bit more into a couple of the differences between sort of sports predictions, and some of the customer predictions. The first thing, which is pretty obvious, when you do a customer prediction, the prediction isn't going to be on the purchase behavior of any specific customer. It's going to be on a group of customers. So against the customers who onboarded in the last month. What percentage of them do we think are going to buy in the next month? And if there are 10,000 of them, then if the model is correct, then whatever 1,000 of them or whatever the percentage might be will actually convert. So you sort of have this numbers game, which is a little bit different. It feels less sort of philosophical and much more reality of what's actually going to happen. Although the model, that doesn't mean that the methods of making the inference are all that different, at a high level. And then the second point is a super interesting one, and it's like, look, in sports betting, ultimately you want the predictions to make money. You need to understand the odds. But in marketing, the pipeline is actually even more complicated, arguably, because you have a probability around if the customer is going to convert or not. But to get them to convert, you mentioned you think about the incrementality. You also have to think about the call to action, the medium, the messaging, the channel. And everything else that goes into actually acting on that to get the probability of conversion from 20% to 23%. And machine learning is not going to tell you, for the most part, whether or not the design of your, the image around your call to action is compelling or not.
No, I think that the framework holds in the sense that both in sports prediction, or the way at least how I was attacking it, and in marketing, it all comes down to understanding these probabilities. The thing is that in the CRM game, for example, if you think about marketing to your existing customers, it is just infinitely more complicated, as you mentioned. So, and I think that so let's take an example of like you just mentioned, channels, et cetera. You can imagine a world where you have, for every single product that you sell, you have some assessment of the probability that a given customer will be interested in that product in the future. And that could be a function of what they bought in the past, whether they already have it, et cetera, et cetera. But then there's another dimension to this, which is that some folks are very comfortable with emails and open them at a really high rate. Others don't. In some businesses, outbound calling is an option. That might be so you have channel preferences too. So that's that 2 by 2. So now there's just many more dimensions to this than what I was doing with this like little NBA model. And then last but not least, probably the most important thing in the marketing space is the concept of incrementality, right? Like now, as I mentioned, if you were to try to bet, you wouldn't just bet on, so let's say Warriors are playing, I don't know, some not good team. I'm going to make anybody mad, but they're playing a really poor team. Sure, I can bet on the Warriors, not going to make any money, right? What I want to do is I want to find a case where where it looks like the model is seeing something that others aren't. Same thing with incrementality. I get no benefit potentially from just marketing to the best customers or just preaching to the choir. What I need to do is find out who are those fence sitters that I can move. And the funny thing is that I think incrementality, I see that now as being much, much more accepted. 20 years ago, that wasn't the case, maybe even 10. But the interesting thing is that in politics, they have understood this for a very long time, right? You know that, if you're going to spend an ad budget, whether you're a Democrat or Republican, it's not California and Texas that you're going to spend those ads. You're going to spend them in the swing states because that's where you win the election. It's the same thing in marketing. You spend the ad dollars or your efforts where you can move people. You get nothing out of just preaching to the choir. Yeah, you see high conversion rates and you can high five about that. But then when you look at the result of the A/B test, you didn't beat your control group, right? So, and so that's that third dimension of the marketing space. There's channel preference, product preference, incrementality. And then the fourth dimension is the contact rules, right? You've got to have very strict contract rules around how many times you can contact people in a given week, et cetera. Yeah. Which obviously requires a whole different database game than what I was using for this NBA model.
Yeah. And before we get into database games in a second, maybe just for a minute, Kim, if you could maybe just for any of our listeners who aren't 100% clear around the difference between attribution modeling and incrementality, what's the difference between the two?
So I think it's the best way to look at it is just that. So let's start with attribution models. There are different ones. I think it's critical to talk about. There's the attribution models for acquisition, and there's attribution models for emails, right? There's so for acquisition, if you run Facebook ads, right, and you get an attribution number from Facebook or a report on how many conversions, what that means is that if you're using Facebook platform attribution, which is the attribution you get directly from Facebook and can inhale via an API, what that means is that if you clicked on an ad or saw an ad on Facebook and then bought the product within some window, that counts as a conversion. But what that assumes is that if I click on an ad or see an ad on Facebook and buy a product, that ad deserves 100% credit, right? But in reality, we know that's not really the case because consumers have an inherent propensity to buy something. That could come from word of mouth, from something else, or maybe another ad, whatever it might be. So obviously, the numbers you get from platforms like Facebook are going to be overstated because some percentage of those customers would have done it anyway. Now, in Facebook's defense, or Meta, I guess I should say, they don't claim that this is incremental. In fact, they allow you to run incrementality tests in their platforms where you go into the auction and you hold your ad back X% of times and you see how it tests and show. So there's nothing wrong with what they're producing. And they don't claim that this is the truth and that's what you should base your ROI off of. It is on us to figure that out. The same thing goes for email. If I email someone and they buy the product within 5 days, that doesn't mean that I drove that conversion. I get emailed all the time and I sometimes open them and I buy them, but it has nothing to do with that, right? I would have done it anyway. And anyone who's ever run an A/B test, I have never seen in the history of my life 100% incrementality. I just have never seen that. Right. So that's the difference between those. And I think, when you hit scale, not so much like the early stages, like series A, B, or whatever, but when you hit scale and there's awareness of you out there, you actually have to get a strong incrementality game, or you're just going to be making a ton of mistakes. You can make them in two ways. You can make mistakes in terms of on the planning front, because if your CAC, your customer acquisition cost, isn't adjusted for incrementality, you might believe that, well, if I spend $1 million and my CAC is X, I can just take $1 million divided by X, and that's what I'm going to get next quarter. Let's bake that into the plan. And then when the quarter rolls around, you got a third of that because you didn't have that level of incrementality. There's also diminishing returns and other things, but that's beyond the scope, I think, of this. And the same thing goes with email. You shouldn't set targets on how many opens you get. You should set incrementality targets. And in fact, I always say, don't set targets on your email game. Just to continue as long as the ROI is positive. So if your campaign is ROI positive, keep doing that as long as it beats the control group. Keep doing it. There's no reason to stop. Keep going until marginal cost equals marginal revenue or marginal profit. You know what I mean? Then you stop.
Yeah, no, those are, it's great guidance. And another example I'll sort of throw in that I like to use as sort of a reference point is, branded keywords. So if I go to Google, I type Whoop. Okay, well, I'm sure Whoop is going to be the first result. But Whoop could also spend a few bucks a click on a paid campaign at the top of that Google search results. In terms of incrementality, I typed in Whoop. I think I'm pretty sure I'm going to get to Whoop eventually. Now if their competitors there, it changes the calculus a little bit. But from an acquisition perspective, anyone who clicks on the ad at the top, they're gonna convert at a reasonable rate.
I love this example.
It's very different than asking, well, if the ad wasn't there in the first place, what's the incrementality around the dollars I spent on a branded keyword search?
I think that one that is such a good example. I mean, you're completely correct. So we have to think about like search is obviously further down funnel. And there's largely two groups of search. There's what you mentioned, which is I buy my own name as a keyword, or there is sort of product level search where I type ride sharing or need a ride, and then an Uber ad comes up. Like that's that's much more incremental than the former. So on the what they call the brand search side, if you meet someone at a CrossFit gym and they say that, hey, the Whoop product is really awesome, which it is, then you could go search on Google and then, maybe someone bought your name, right? And that comes up. But if you were about to buy a Whoop strap, you would just all you just do is the organic link is right there, right? You can just click on it. Same thing if you want to buy any kind of product, and you have high intent, you don't need this brand ad to change that. That's why there's all the incrementality tests I've ever done on brand search have shown no incrementality. And what it does is it just cannibalizes organic. So you just see a shift. Now, there are some cases where you could argue, and by the way, calling it brand search, I think has...
There's a little bit of Google branding, if you want my opinion.
It's sort of like, calling it brand search is, I have talked to people who said, I hear you, and not so much, but 10 years ago, people would say, I hear what you're saying, but we think it's really important for our brand. I'm like, wait a minute, this is not, if you want to build your brand, you can run brand ads. That's a whole different thing, right? Those are cool videos where you talk about your brand. Putting a link in Google is not branding, you know what I mean? So calling it brand search it doesn't really make any sense. I would say that you can come up with some examples of where this notion of brand search could make sense. So say you are a product where you sign up people for the gig economy, for example, could be anything. And your ad says, come, drive for company X or whatever. But then there's another company that does the same thing. And they say, come drive for us or come work from us and get a $2,000 bonus. So now I was looking specifically to drive for one company, but the other one bought my keyword and promised a bunch of money. So now you could have a fight where actually you could argue that you should push back on that. And now you're kind of getting into a situation where you're outspending each other. But that's the only case I can think about where it would work. And even that I don't really believe in, but there's a case there.
Yeah, 100%. So maybe a minute, we'll go back to data quality, and then we'll get to the sort of last question, our last question here. But maybe you can just give some guidance around, really, if you're going to do this properly at enterprise scale, how to build a robust customer database and what that looks like.
We talked about the model there. It runs off of box score data. And the next question is, of course, well, how could I make it better? Okay, so I got right in high 60% of the time. The coin flip is 50%. So I'm 30 to 40% better than a coin flip. But what if I wanted to be even better than that, right? And unlike sort of quote unquote, the world of AI, like image recognition, speech, like that, those like really hard problems in our world of kind of, row by row customer data. I don't think you win by unleashing a more sophisticated model or like getting into neural networks and all that kind of stuff. I think you win by digging up new variables about those customers you never thought about. So if I had to improve this model, I would actually need to go to the play-by-play data, which is very, very messy and long. And I'd have to infer from that data who has the ball at any given point in time and what did that person do and what happened. Then I would have to create late game archetypes instead of just box score archetypes. And I would need to take these archetypes into consideration into my model. And I think I could get a lot of traction there because there's heterogeneity. There's like there's an interaction between archetype and late game performance that I'm not seeing right now, right? But this takes us back to CRM, or, obviously nowadays most data stacks look more and more the same. You've got all your kind of first party data sources and Salesforce and Stripe and Shopify and all that. And then you have 5 train connectors or whatever you're using, or Airbyte or whatever, running into some staging tables. And then there's an ETL process and DBT is involved somewhere. And you end up with these like tables in Snowflake and Redshift. Like that's what most people do, like in my world. Now, I think that often what happens is that these data warehouses are actually still quite granular and requires a lot of tribal knowledge and joining of stuff, et cetera, and knowing certain things. And I think that where you really win is when you boil it up to a higher level and you have these very, very clean summary tables. One thing I'm particular fan of is this notion of event streams or customer contact repositories. So I could literally look at any customer in sort of every single contact I have, inbound or outbound contact I have contacted them with, anything they did, when they did it, just a full history of the entire relationship. That goes back to, if I want to take my MBA to the next level, I have to have a full history of the game, possession by possession, writing logic to understand who has the ball, and that involves like substitutions and stuff. Can't be that easy. Data also gets bigger now. It's the same thing. Once you have that, now you can get into this game we talked about earlier. Now I can start to understand channel preference. I can understand time since you did last thing, the temporal stuff, channel preference, product preference, all of these types of things. I can start to build propensity models around that. So I have a propensity to do X, Y, Z over time, combine that with channel preference based on propensity to respond to certain channels. Of course, you got to get the incrementality in there somewhere. Then you slap an optimization layer on that, where you're saying, well, okay, what is the propensity? How much money would I make if they actually do this? And what is now the best move for me for that customer at this point in time? Because I guess it isn't static. And this works so much better than human targeting, which is like, well, we think because someone doesn't have a college savings account, they should. But you don't know. Do you know what I mean? Like,
Yep.
like the humans are terrible at targeting, by the way. They're really bad at it. They're good at many other things, but not targeting. They should stay out of that game and just tell the models what they need to do with some, restrictions around it. And I think you get much better results.
Yeah, no, 100%. And, I couldn't agree more with you that, data is everything. And, back to the NBA, I mean, a lot of, there's been a lot of analysis that shows that, superstars win championships. And superstars can turn it up, in the last minute of the game. Kobe Bryant, exactly. Michael Jordan taking the game-winning shot. They're not taking that shot with 40% probability. You don't have access to that data around what does performance look like, not over 48 minutes of the game, but over the last, 1, 2, 3 minutes of the game. You're certainly losing some fidelity around actually building an accurate model. It doesn't matter how smart your algorithms are. If the data isn't there, ultimately quality needs to begin and end with the quality and specificity of your data.
Yeah, I completely agree.
Great. So Kim, last question. If you could have this conversation again with anyone in the world, who would it be and why?
It's such a good question. So obviously, we've talked about this at length also outside of this. And we both think about it from like a data angle, you know what I mean? So I was kind of debating this in my head. I would either have to be someone who is from the world of basketball, who isn't technical, or doesn't work as a data scientist. So it could be anyone, whether it be
Nick Vital,
Steve Kerr, like, or like, or something like that, or a player like, any superstar. That would be fun. But I also think another person that would be really interesting to talk about is Malcolm Gladwell. So I was listening to a podcast where he talks to Rick Barry, and there's a whole podcast around shooting free throws the way he did it, from between the knees, essentially, as opposed to, and how that in many ways is better, but no one wants to do it because it looks silly. Yeah. And that was just an amazing discussion. And I think every time I listen to Gladwell, I think about the world in a different way. So I would probably pick him if I could. Yeah.
Got it. Now that's great. Cool. So closing out first, Kim, thanks for coming on our podcast and sharing your wisdom with us. You really enjoyed the conversation. I think first, back in sort of, late spring, early summer, when you're making the predictions, I was rooting for the Brooklyn Nets, being a Brooklyn resident, and the outcomes were not good for me, unfortunately. It was really great to take a step back, reconnect, and talk about, some of the brass tacks around how the models work, and then just relate that back to, a bigger set of problems that I know every one of our listeners in the podcast today, care deeply about. And that starts with understanding customers, really, going and trying to predict their behavior and then responding in a way that is actionable, engages customers and ultimately drives, incremental revenue.
No, it's interesting that as long as you deal with data where you have like customers and rows and businesses, I honestly find that the stuff we're doing today is exactly the same stuff we were doing 20 years ago. Only difference is the technology is just much better now, and I think that is the big difference. But they're the same problems and largely the same way we're going about it. It's just technology is better, and you have a lot more people in the field. It used to be more sort of statisticians like myself, and like now you have folks from all sorts of areas getting into data science. And because the open source community and the tools are better, you don't need to be able to write down exactly how you apply a penalty parameter to like to fit a logistic regression model, and like you don't need to like be able to know that. You just sort of, you can operate at a slightly higher level and still be quite good. And I think this is really interesting to see, and has really helped the field.
Yeah, no, 100%. And obviously, on our end, from a Simon Data perspective, we're tremendously excited by the advancements in data and be able to bring these technologies outside of sort of trained statisticians, to your point. And so, Kim, so anyone who wants to learn more about Whoop, where should they go, and where can you point them?
Yeah, you could go to whoop.com and check it out. The website is nice. There's also a podcast, a Whoop podcast, hosted by our CEO, Will Ahmed. That's another really good source of information Whoop's about. I started using Whoop before I joined the company and sort of got addicted to the data as a data person, but you don't need to be a data person to enjoy it. But I really got addicted to seeing details on my sleep, my recovery, my strain, and how all that comes together. I actually think it taught me some really critical things around how I can get better sleep and be better recovered. And I do notice that when I'm better recovered, I'm just sharper, right? And when I'm in the red, I'm just not as sharp, and I'm more kind of prone to sort of not want to engage in a good debate because you're just not there mentally. So it has really helped me as a person, and we're constantly rolling out new features, so there's more interesting stuff coming. This is a growing space, of this level of data from wearables. Yeah.
Awesome.
Yeah.
Well, thanks for that, Kim. Yeah, definitely a super, super cool product. Encourage everyone to check it out. And thank you to everyone listening to this episode of the Data Unlocked podcast. If you'd like to learn more about Simon Data, please visit us on the web at simondata.com or email us at hello@simondata.com.